Hello students, my name is Ankit Mittal and today we'll discuss a small topic from application of derivative, that is concavity and inflection. Concavity, as it appears from the word, describes the shape of the curve in any particular region. So let's see, anything in a very layman language, anything that is like this is called concave down, and anything that looks like this is called concave up. So these are the two shapes that we'll discuss. Now let's take it to a little formal definition. We can see if we draw tangent to a concave down curve at any point, let us say this or this, the tangent line is always above the curve and above in the vicinity of this curve. So if I take immediate neighborhoods, the tangent line is the line that is above this curve. Similarly, if I take the immediate vicinities here, the tangent line is always above the curve. Whereas if I draw tangent lines on a curve that is concave up, the tangent line is below the curve. The tangent line is below the curve in the vicinity of the point where concavity is being discussed. Right, so this is a more formal definition. In a concave down curve, the tangent line, the portion of the curve which is concave down, the tangent lines will be above the curve in the vicinity of the point where concavity is being discussed, right? And if it is concave up, it will be vice versa. That is the portion of the curve which is concave down, the tangent line will be below the curve in the vicinity of the point where concavity is being discussed. So this is the basic and simple idea of concavity, right? Now the second point is, for which curves can we discuss concavity, right? Let us say there is a curve like this. Can we discuss concavity of this curve at this point? No. Concavity is the shape of the curve. If it is a straight line, or if a point is there that is not differentiable, we'll not discuss concavity. Concavity will be discussed only on the points where a tangent can be drawn, right? So if a tangent cannot be drawn, for example like this, if a tangent cannot be drawn on this point, concavity at this point will not be discussed. We can see from here to here, the curve is concave down. From this point to this point it is concave down. Similarly, from this point to this point it is concave down. But at this point, concavity cannot be discussed. Right? So only those points where a tangent can exist, concavity will be discussed only on those points. So this is the basic of concavity. Now if a tangent exists, this means either there will be a vertical tangent or the function will be differentiable. So let's start with functions that are differentiable and how can we find out whether the function is concave up or concave down. If I draw tangents at this curve, I can see these are the tangents, and if I draw these lines parallel to these lines on xy axis, this is going to be like this: 1, 2, 3, 4 and 5. This line appears to be flatter than this, means if this is 1, this is going to be 2. This line gets a negative slope. This line gets a negative slope, obtuse angle. Okay? So this is like this. Now this line is more towards y-axis, 4. So this is 4 and this is further towards y-axis. Now we know the slopes of this line can be arranged in which manner? The magnitude of the slopes, let's discuss. This is a positive slope and this is a negative slope. For 2 and 1, the slopes are positive. For 4, 5 and 3, this slope is negative. So lines 1 and 2 will have positive slope, whereas lines 3, 4 and 5 will have negative slope. If I consider M1 will be maximum, then will be your M2. Coming into the second quadrant, I know tan theta is minus infinity here and 0 here. This means which is the next in this order? Obviously M3, because M4 will be negative but with a greater magnitude, so it will be less than M3 and so on. So there is a peculiar pattern that we are seeing, that the slopes of these tangent, जो tangent के slope हैं ये क्या हो रहे हैं? घट रहे हैं. ठीक, सबसे पहले 1 आया, बढ़ा, सबसे बड़ा, फिर सब उससे छोटा, then उससे छोटा and so on. इसका मतलब slopes of the tangents are decreasing. So I can say f dash x is decreasing. Why? This represents the slope of the tangent to fx at any particular point. अगर fx की डोमेन में किसी भी पॉइंट पे f dash x निकाला जाए तो क्या नोट करता है? टैंजेंट का स्लोप. अब टैंजेंट्स जो बने हैं उनका स्लोप घट रहा है, गोइंग फ्रॉम लेफ्ट टू राइट. दिस मीन्स f dash x is a decreasing function. So if a function is differentiable, I can say if f double dash x is negative or equal to 0, then fx will be concave down. Now this equality has a meaning from here. F dash x is decreasing. Now if f dash x is decreasing, f double dash x must be less than 0, but it can be equal to 0 only at some discrete points, not in a complete interval. So this is the definition that we are using from increasing decreasing functions. Take f dash x should be decreasing. This is the basic conclusion that we have drawn. If f dash x decreases, this means the function will be concave down. Now for f dash x to be decreasing, we can discuss it in terms of f double dash x, that f double dash x must be negative or less than 0. If this is true, then f dash x will be decreasing. But this equality can hold only at some discrete points. It cannot be 0 in a complete interval. It can be 0 but only at some discrete points. So for a differentiable function, for a twice differentiable function, we can find concave down curve by double differentiating it. If it is less than 0 or equal to 0 and equality holds only at some few points, then the curve will be concave down. Let's move to concave up. Concave up must look like this. So if I draw tangents, this will be like this. Again, let this be 1, 2, 3, 4 and 5. Again we'll discuss the slopes. If I draw this, now starting with 1, it is on the negative side and most straight. Second is this, then your third is in this case parallel to x-axis. Then comes your fourth and then comes your fifth. Now you can arrange. M1 is the least. M2 is greater than this. Obviously a 0 is greater than a negative value. Then comes your M4 and then comes your M5. This means the slopes in this case are in increasing order. I can say f dash x is increasing. This implies for a concave up curve, the function f dash x must be increasing. This implies f double dash x must be greater than or equal to 0. But equality can hold only at some discrete points. Right. So this is how we relate concave up and concave down to the second order derivative of a function. Let's continue. Let's take an example. There is a function that is fx is equal to 2x cube plus 9x square plus 6x plus 1. Right. Now we have to know the shape of the graph in different intervals. Since it is a polynomial, it will be differentiable. Let us differentiate it. So this is 6x square plus, let us differentiate it one more time. 6 you can take common. This is 2x plus 3. I can also write this as, this implies f dash x is 0 at x equal to minus 2 and minus 1. This value will be 0 for two values of x, minus 2 and minus 1. And f double dash x, if we see the sign of this, because if we are to find out concave up or concave down portion, then we must know the sign. If f double dash x is positive, it will be one sort of curve. If f double dash x is negative, that is f dash x is decreasing, then it will be different. So let's say, solving this linear inequality, I can say this is your point minus 3 by 2. Any value that is bigger than this, f double dash x will be positive. Less than this, f double dash x will be negative. Let's try and plot a rough graph of fx. I know f dash x is getting 0 at 2 points, minus 2 and minus 1. This implies the tangents to fx will get parallel to x-axis at x equal to minus 2 and x equal to minus 1. Now fx is a cubic polynomial with positive coefficient. So if we have to draw fx, we need to find fx as x tends to minus infinity, fx as x tends to, obviously this is going to be the dominating factor, so the fx will tend to minus infinity and fx will tend